Welcome to part 6 of analytical geometry, the final part. And this one we're going to look at tangents. And there's 6 videos in this because each example is going to have its own video. Hopefully that gives you a sense of the fun we're going to have. So let's jump into a definition and then one example here. So tangents. Tangent touches a circle at one point only. So if you've got that point and this tangent, then the circle and tangent intersect just at that one point. Second idea is that the tangent and the radius are perpendicular. So if we've got a radius, then they're at 90 degrees. So hopefully you already, before seeing this line, thought, I'm sure we're going to use gradients and their product's -1. So, if the one's 2 over 5, then the other one's -5 over 2, right? That hopefully is that sense we're getting now. And maybe just a third idea is that we might construct a triangle here, and then we've got a triangle, a right angle triangle. We can use Pythagoras. Okay, so one example for this. Determine the equation of a tangent to this circle here at some point. Okay, so that point must exist on the circle. Let's just check. -3 squared plus 1 squared. Yes, that makes sense. So hopefully, a lot of hopefully is going on here, but hopefully you see the circle and you go, oh, well, this circle is just centered at the origin. So if you were to draw a quick sketch on the Cartesian plane, you might go, well, that's not going to be too bad. I just draw up a set of axes here and I can draw my circle looks something like that. And that point in the circle, -3, 1, -3, 1 is somewhere over there, -3, 1. And yes, definitely draw a little sketch. You can see I draw my sketches without getting the circle tool or worrying too much about perfect circles and straight lines, because I just want the sense there. Obviously, they need to, to a point a little bit better. So this tangent to the circle must look something like this. And we should have our sketch close enough that we know that it's got a positive gradient. And look, it's kind of going up. So we already said that if we drew a radius, then the radius would be at 90 degrees to the tangent. So here's a point 0, 0. So in other words, if we can work out the gradient of the radius, we can easily work out the gradient of the tangent. Okay, so let's work those things out. The gradient of the radius will rise over run. And I'm going to go from this point to this point, 3 and 1, but it must be in a negative direction, -1 over 3. And that's where the sketch is quite useful, because I can trust that that should be a negative gradient. So I'm not going to have that as a positive by mistake. Okay, then if we move to the gradient of our tangent, notice that I've got gradient and then a subscript R, gradient, subscript T. So we're just explaining ourselves quite well, then this will be +3 over 1. So we know that we've got y equals mx plus c. Okay, so things should be looking fairly good there. Y equals mx plus c. And we need to find out what the value of c is. And we've got 2 options. Remember, we could go for that idea of, we could go across by 3. So we're going up by 9. So it should give us 10. Or we can go, y equals mx plus c, c equals 10. So whichever you're more comfortable with, of course, substituting in just gets us there and we don't have to think too much about it. So our final equation is y equals 3x plus 10. And our sketch, I can trust enough to know that we should have a positive y-intercept, a positive c value. If we got c equals -10, it doesn't work with our sketch. So you're always just checking these things at the same time. Okay, that's it for the first one, just getting into tangents. See you in the next one for another good example.